Hi, Mike Matchett with Small World Big Data, and we are here talking about one of the most groundbreaking changes that are coming to data centers and the cloud everywhere, and that is being able to compose memory, being able to take memory and make it really an asset that you can do all sorts of things with, like we do with virtualization today. We are here talking with John Spiers, who's the CEO of IntelliProp. We are going to dive into memory and talk about what's new with memory. Memory is changing. Memory is becoming composable. You've seen some other things here on this channel before about composable. Now memory is it. Welcome, John.
Thanks, Mike. I really appreciate it. And I'm here with IntelliProp, and we're really excited to talk about our capabilities and the future of the data center. We're really seeing disaggregation, kind of the first wave of disaggregation of the data center. And it's all about improving efficiency, improving performance, and disaggregating resources so they can be shared and dynamically allocated. And really the last link in composability is the ability to disaggregate share memory. And so that's what IntelliProp's all about. We're developing technology that allows you to move memory outside your server and have servers share it, all using load store NUMA technology, and your applications don't need to change. And this is going to be a game changer because like the storage industry in the early days, where NAS and SAN came about because of the stranded storage and servers and the lack of utilization, memory has the same problem, increasing core counts. Lower memory bandwidth per core is creating memory bottlenecks everywhere. Databases need more memory, AI, ML, you name the application, they're getting more and more memory hungry, and you can only stuff so much memory on the motherboard. So how do you expand that? Well, today you can share memory across servers using RDMA, which is kind of clunky. Another clustering technology is very complex and clunky, and to do cache coherency across compute domains is very complex in today's programming world. What CXL does, and CXL is an emerging standard that's being developed by a lot of smart people, and really, is the foundation of what IntelliProp's doing. It allows you to disaggregate memory, share memory, move memory outside the server, and have not only your CPUs share it, but your GPUs, your DPUs, and creating this dynamic memory pool that can be allocated on the fly. And when you run out of memory on a server, you can not only expand it by plugging in what looks like an SSD, but it's a memory drive to the front of your server. You can add what looks like a disk array or SSD array is now a memory array external to your server, and have all those servers share it with all the great features of multipathing, failover, security, encryption, and all those capabilities. So that's what we're building in IntelliProp. We're building a network attached memory system that is fundamentally changing the performance, efficiency, and cost of data centers.
All right. Well, that's a great pitch, John. This is not your first rodeo either, right? So you were instrumental in Left Hand. You were instrumental in Next Gen. You've been in Liquid. You've been working through all these things. Now we're getting to memory. Is memory really sort of this final frontier of getting the data center finally automated and unplugged and meeting the needs of what people want to do for security, performance, efficiency? Basically, the whole reason for digital transformation and cloud journey here. Is this what we're trying to do?
Yeah, I mean, I think this is the last piece of the puzzle to get data center architecture to the way people want it, right? There's been a storage bottleneck, and so now there's shared storage. There's clustering technology that allows you to share compute resources, but it's really efficient when sharing memory. A lot of the memory in data centers and hyperscalers is stranded. And Google and others came out and said, memory utilization is 50%. And, that's a huge cost when you consider memory is 50% of the cost of a server. And those guys use hundreds of thousands of servers. You do the math on that, it's billions and billions of dollars in wasted money sitting there in idle DRAM. What this technology allows you to do is disaggregate it, share it, drive the utilization up, and your applications don't need to change. A lot of technologies that hit the market are, oh my gosh, I got to redo my software to use that technology, and adoption is slow because of that. Well, this is plug and play with your existing software. It just sees it as more memory out there, and you can allocate it just like you do memory inside the server. So yeah, we see this technology really transforming data centers and improving utilization of DRAM, lowering the amount of DRAM you need, and lowering, as you know, everybody replicates data everywhere to work on it.
Okay.
And it's memory, these data models, machine learning models, databases are getting larger and larger and larger. And when the data is spread everywhere, you're processing chunks of it everywhere and then bringing it back together and then moving it to flash or disk and then bringing it back. All that data movement and it costs money and power and utilizes resources and is inefficient and slow. If you can move all that data in one place and have everybody work on it simultaneously in one pool, it really helps. And memory is a key to performance, and a lot of these data models need DRAM type performance, and to boost the time it takes to do inferencing and AI and
Right.
come to conclusions, right?
Right, we can't just virtualize memory. I mean, we've had virtual memory ever since the beginning, right? Where we have a RAM disk and virtualize our memory. It's not really about that. This is about composable. And guys, if you're not sure about the difference between virtualized and composable, we can get some pointers for you on some of the other things we've covered here. But with this idea of composing stuff, you're physically taking the memory and making it available to multiple endpoints, I guess, the CPU, the DPU you mentioned, the GPUs, at the same time in a pool that crosses nodes and crosses networks, right? So CXL, this protocol in there, or is CXL, do you call it CXL protocol or a management layer? Let me start with that.
Well, it's a technology that sits that uses PCIe as a transport.
Okay.
But PCIe has a lot of issues as far as PCIe switches, for example. The latency through a PCIe switch is microseconds, and so the latency with today's PCIe technologies fairly high, and it's not acceptable for memory. So you need to be in the nanoseconds, the hundreds of nanoseconds kind of latency to make it make it worthwhile, or being able to even have applications use it. You have to make it performant. So the technology to make PCIe not only performant, but highly available with multipathing failover and having security and all the things that you need, that's where CXL comes in. CXL builds that stack and uses PCIe as just the transport layer.
Okay.
And then throws the rest of it out and does what it needs to do to create a fabric of memory and make memory shareable.
So analogous to what we did with SAN and NAS, you mentioned that you got fiber channel and some other protocols there that allowed you to aggregate, take storage out of the boxes by disaggregating it, and then aggregate it somewhere else in a big pool, and then network attach it into a fabric. We're basically doing this now with memory. This is what you're about, right? So you've got CXL as a way to build network attached memory systems that we can plug in, as well as share memory between servers so nothing gets isolated. I think there was a big thing about GPUs just recently being highly shareable. Everyone's talking about that. I don't want to isolate my GPUs; those are expensive. Memory's expensive too, and I don't want to isolate that. I want to share that. So this seems to be coming together here. When can we start to expect to see this hit the market? When is this coming?
Well, you'll see Sapphire Rapids from Intel this year with CXL version 1.1 on the motherboard. This will allow you to do memory expansion in the server. Okay. So think of like I talked about earlier, not a SSD drive, but a memory drive that plugs in the front of the server chassis. And Intel's CXL chip sees that, incorporates it in the DRAM pool, and now applications can use that. And there will be various chips out there that pool this together and provide certain management of CXL memory in the server. And so that'll be the first wave of adoption later this year and next year. And then towards the end of next year, you're going to see IntelliProp like technology that allows you to disaggregate the DRAM outside the server, and have servers and GPUs share the pool of memory outside the server in a kind of a NAS and SAN way. And that's what we're all about.
Okay, and you're not alone in this ecosystem going down this path. CXL was a hot topic, I understand, at some recent shows. How would you position IntelliProp within that, just so people can keep clear? Like, what is IntelliProp focusing on with this network attached memory?
Well, we believe we're the first to offer memory disaggregation outside the server.
Okay.
Most of the CXL guys out there now are focused on expanding memory within the server using CXL, but having shared memory outside the server is really our thing. And there's a lot of companies involved with the standard. Hiran Patel, our founder, has been leading this effort. He was the chair of the Gen Z working group, which is now part of the CXL working group. And we're actively involved in developing this standard. Every company you can think of is involved with this standard. You have AMD, Intel, and all the big OEMs, and pretty much everybody and their mother is involved with the working group. And so this is going to be an industry-wide adopted standard. It's going to evolve. It's going to add features and functionality over the years. We believe we're skating to the puck where it's going to be years from now, to be able to make this an external switch fabric and sharing memory systems outside the server. We believe we have a design that's going to be first to market with that capability, and we're very excited. This ecosystem is wide and broad, and we're partnered with a lot of different companies with this technology, and are excited to help build that transition for the data centers.
All right, so there's a lot to dig into here, because I think we've just sort of opened Pandora's box a little bit, right? Because once you start getting into what you need to build a shared memory fabric, you start worrying about security and performance and management layers and multi-tenancy, and you have answers to all that in there. But we don't have time to cover it right now. So where can someone go to maybe find out a little bit more about what you guys are doing with CXL?
Well, you can go to the CXL consortium website. There's a ton of information out there. And then, just a Google search on CXL, there's been tons of articles written and white papers, and Carnegie Mellon's done some testing, and Microsoft's done some testing. Their preliminary results, and I think it's FPGA based CXL testing, they said they can reduce the amount of DRAM in their data centers by 10% based on the work they've done with it already. And that's hundreds of millions of dollars, right? And so you're seeing the large hyperscalers rolling up their sleeves, getting involved, starting to test this stuff. So we're really excited, and it's probably the most collaborative effort I've seen in the industry. There was some jockeying in the early days of, CXL versus Gen Z. Well, CXL doesn't have the Gen Z fabric features, and, this, that, and the other, and Open Compute Project and other things that are developing standards. Well, it's all coming together under one roof called CXL, and to the benefit of the industry. And there's a lot of exciting things happening across multiple companies.
All right, so if you thought that Composable was going to change the industry, this is really the final brick for Composable, which is composing memory across that.
Yeah.
So, I'm all for it. So I'm excited to see where this goes. Thank you so much for being here, John. I hope to have you back when you've got some more things to show us, because this is just the first step, I believe.
Yeah, it totally is, and we'll stay in touch, and we'll be back.
All right, thank you very much. Take care and check out IntelliProp.